Simplifying rational expressions. What we basically have right here, guys, is we have rational expressions, right? And you can just tell by the way, or just take a look at these two right here, we're dealing with fractions, all right? Now, the fractions are going to be more complicated than just 2 over 3 and 1 over 2. But the rules are pretty much the same. We're trying to reduce the fraction and get it into its simplest form. No kidding, simplify, right? And by doing that, we basically have to eliminate the things that are the same. We're going to have to cancel out common factors, which is a big plan of what's going on right here. Now, you also see right here is that now we have variables in here which we have not had before. Factoring is going to be huge. Factor, factor, factor. All right, so kind of some rules that you have going through these is going to be this. We need to factor the problem entirely first. All right, so factor the numerator, then factor the denominator, then cancel out the things that are the same. Okay. The first couple of problems that we have right here are as simple as we can make them. It's a good starting point for us, though. Looking at this, 4x divided by 20x cubed. Okay, so if I broke this all the way down, I would have this 4 over 20, and then I would also have this x over x, x, x. Now, that's as drawn out as I can make this, right? The 4 over 20 part, man, those are my coefficients. Those are my numbers that I have to divide out. We can simplify that fraction. The x's, on the other hand, if you draw them out like that, then it's easy to cancel out the things that are the same. If we look at the 4 and the 20 right here, the greatest common factor between 4 and 20 is 4. And so 4 divided by 4 is just 1. 20 divided by 4 is 5. So that's what we have right there, okay? Now, over here with the x's, I've got one x on top, and there's an x on the bottom. Now, there's no more x's on the top, are there? I see none. And there's 2 x's on the bottom. So we're going to write it like that. So in the end, there it is. That's as simplified as I can make that rational expression. I know it says you try over here, but again, this is the video lesson, so I'm going to handle it with you entirely. Again, take the numbers, the coefficients that we have, 14 over 50, and then there are 7 x's across the top, and there are 3 x's across the bottom. Okay, so how are we going to reduce 14 over 50? Greatest common factor between those two numbers is 2. So 14 divided by 2 is 7, and 50 divided by 2 is 25. And now what are we left with as far as the x's are concerned? There's an x on top and an x on bottom. They're gone. An x on top and an x on bottom. They're gone. An x on top and an x on bottom. They're gone as well. There's no more x's in the denominator, and there's 1, 2, 3, 4 x's in the numerator. So that becomes the simplified version of this. Maybe some of you are starting to get the idea as well. When I'm dividing right here, if you take a look at these numbers, all I'm doing is the top number, with the, when I'm dealing with like terms anyhow, I'm dealing with the exponent on the top and the exponent on the bottom. What's 7 minus 3? I end up with 4, right? And I know I put a 3 right here, and that's incorrect. That should be a 4. Okay. Moving on, let's make them a little bit more complicated. Now the rules come into play big time, okay? And we're talking about you got to factor, factor, factor. That's got to happen first, okay? Okay, we're not going to get into a big lesson of how to factor. Hopefully you guys are starting to gain those skills pretty quickly, but you're going to get to do it over and over. The most common that we have is I look right here, I got the x squared, and there's 3 numbers, so you need to do the diamond technique. There's absolutely nothing to do up here on the top, so all we're going to do with the numerator is rewrite it. So I've got x minus 5 over, and now the factored form of what's going on in the denominator is x minus 5 and x minus 3, okay? Now, here's one thing that you guys got to keep in mind. When we're doing the same thing that we did with the first fraction that we have, and I'm eliminating things that are the same, it's got to be like this. When there's a plus sign or a minus sign in between the variable and the number right here, it's all or nothing. You can't just cancel out the x or just cancel out the 5. And I can't say that enough, and I can't stress the importance to that. It's all or nothing. So you either take the whole thing that's x minus 5, or you take none of it. Okay, so that's going to be the way that that breaks down. Now, this is when we have them factored. So on the top, I got an x minus 5. Is there an x minus 5 in the denominator? Obviously, there is. So those two guys are gone right there. So what we're left with in this case is there's nothing on the top, right? So if there's nothing on the top, you just put a 1. And then what remains in the denominator. So 1 over x minus 3 becomes the result of that thing. Take a look at the second one again. X squared plus x minus 20. The way that I factor that, diamond technique again. So it becomes x plus 5 and x minus 4. And the denominator, again, the rules are factored completely. In the denominator, I got to do the diamond technique again. And when I do that, I get x plus 5 and x minus 3. Now, again, I'm going right to factored form, but you're going to have to, on the side somewhere, actually do the technique that is the diamond technique, or grouping, or greatest common factor, or difference of two squares, and find out what your factored form actually looks like. So now, again, can't eliminate one or the other. I've got to eliminate everything inside the parentheses. So here's an x plus 5. Is there an x plus 5 on the bottom? We're in luck. Both those guys are gone. Now I have x minus 4 and x minus 3. Those are different. So the result is x minus 4 over x minus 3. There's my finished product. The last one that we have, and I know it says you try, but that's me. So on the top, there's nothing to do on the top, so I got x minus 3. On the bottom, x squared plus 5x minus 6. You would have to do the diamond technique again, and when you do that, you end up with x plus 6, x minus 1. So now this one's interesting. If you look in the numerator, I got an x minus 3. Again, it's all or nothing. You got to cancel out the whole thing or none of it. So x minus 3, I'm looking for an x minus 3 anywhere. Do I see one? Do I see one? It's not there. So guess what? This is actually already in simplest form. Okay, so you leave this guy entirely alone. Last two that we have right here, and again, there's just some different ways that I'm going to go about the process of factoring. So on the top up here, factor completely, x plus 3. I can't do anything with that. So x plus 3 does not factor. And now I have x squared minus 9. Hey, x squared is a perfect square. And 9 is a perfect square. And there's a minus sign in between, so it's a difference of two squares. And when we factor that, you recall, we get x plus 3 and x minus 3. And now again, all or nothing. So it's everything on the top's got to go or none of it. So we look for the things that are the same. And I got an x plus 3 up here. And lucky me, I got an x plus 3 on the bottom as well. So now in the end, there's nothing on the top anymore, so we're going to put a 1 there. And the only thing left on the bottom is x minus 3. And there's my simplified form right there. Okay, guys, the last one that we have right here, again, a different way of factoring. Factor completely, first thing, so in the numerator, how would we factor that? Well, it's a 3 right there, so I know it's not a difference of two squares. There's only two numbers right here, so I know it's not FOIL. Or excuse me, it's not the diamond technique. There's not 4, so it must not be grouping. So the only thing that we could have is greatest common factor. And if you look at these guys, I got a 3 and an 18. The greatest common factor between 3 and 18 is 3. Now they both have an x, and the lowest exponent is 1 right here. So 3x is coming out of there. Now what's left here? 3x squared divided by 3x is x. 18 divided by 3 is 6, and x divided by x goes away as well. Now, how are we going to simplify or factor the numerator when there's just basically one number right here? Well, I would do this. You see this 3 right here? Can I divide 9 by 3? Yeah, we can. So let's do this. 3 times 3 times x times x. And again, that is as drawn out as I can make it. 3 times 3 is 9. X times x is x squared. So this right here and this right here are the same, but what's here is just in factored form. Again, eliminate the things that are the same on the top and the bottom. So there's a 3 on the top and a 3 on the bottom. They're gone. There's an x on the top and there's an x on the bottom. They're gone. Now again, inside the parentheses right here is an x minus 6, but they're together in the parentheses. So if I want to eliminate that, it's got to be all or nothing. And there is no x minus 6 in the numerator or in the denominator. So guess what? These are done. You can't do anything more with that. In the numerator, we have x minus 6. And in the denominator, we have 3x. That's the end of that, guys.